This hand, this knee, and this head are small feats of engineering, decades in the making. Together, they're about to take a massive leap forward. But look past the carefully edited promotional videos. This isn't sci-fi. It's happening right now. What the tech industry hides are the countless unreleased blooper reels of multi-million-dollar machines collapsing under their own weight. Behind the viral dancing routines is a dangerous, multi-billion-dollar bet. A frantic race to force artificial intelligence out of our screens and into the chaotic physics of the real world. For the past decade, AI has lived inside a vacuum of pure language and pixels. But a massive paradigm shift is underway, one that could set humanoids up to become a multi-trillion-dollar market by 2050. Tech giants are trying to crack the code of physical AI, taking specialized neural networks and locking them inside physical bodies packed with sensors, high-density batteries, and incredibly complex, highly expensive actuators. This isn't just about building smarter tools. It is about building a completely new biological proxy. The next 10 minutes will reveal the hidden engineering bottlenecks, the quiet geopolitical data wars, and the unspoken psychological cost of the machines designed to rewrite the global labor market forever. For years, we fell for the illusion of movement. When a robot danced or did a backflip, we assumed it was intelligent. But those were rigid, pre-programmed puppet shows, every single step calculated by lines of static code. The moment you move that machine into an unpredictable real-world environment, it shatters. The industry reached a hard wall, realizing that building the metallic body was actually the easy part. The real nightmare began when engineers realized their multi-million-dollar creations lacked the basic sensory-motor survival instincts of a biological insect. And the reason for this catastrophic disconnect dates back to a forgotten scientific law discovered in the 1980s. In the 1980s, a group of radical AI pioneers named Hans Moravec, Rodney Brooks, and Marvin Minsky stumbled upon a bizarre, counterintuitive reality that would paralyze the field of robotics for the next 40 years. It became known as Moravec's paradox. The core concept is deceptively simple, yet utterly devastating to early computer science logic. The paradox dictates that high-level reasoning tasks, things humans consider incredibly difficult, like solving advanced calculus, analyzing complex tax codes, or defeating chess grandmasters, require remarkably little computational power for a machine. But low-level sensory motor skills require an absolutely monumental amount of computational intelligence. This massive disconnect is rooted in a fundamental biological blind spot. When you reach down to grab a cup of coffee, your brain doesn't just execute a single command. It relies on billions of lines of unconscious biological coding, honed and optimized through 4 billion years of merciless evolutionary pressure. Your nervous system is constantly executing hyper-complex vector mathematics, shifting bone vectors and balancing your weight. You do this without a single conscious thought. But a machine possesses no such evolutionary lineage. To an artificial neural network, a wrinkled piece of fabric represents a catastrophic, chaotic wave of unpredictable pixel data. The machine does not see a cup. It sees a shifting matrix of millions of independent numbers. For decades, Moravec's paradox was considered an unbreakable wall in robotics. But right now, tech titans like Tesla, Boston Dynamics, and OpenAI believe they have finally found the ultimate exploit. They call it kinematic intelligence, and they are using it to build something terrifyingly efficient. While artificial intelligence software is growing at an exponential rate, the physical hardware is trapped in a brutal mechanical bottleneck. The grand illusion of Silicon Valley is shattering against the cold laws of physics. The crisis is twofold: power consumption and mechanical actuation. Consider the brutal energy mathematics. Running a multimodal AI world model locally, requiring trillions of calculations per second, inside a moving 150-pound metallic frame, demands an insane amount of electricity. Right now, the world's most advanced humanoids can only operate for 30 to 60 minutes before their high-density lithium batteries drain completely. A human laborer can work an intense 8-hour shift powered by a single bowl of rice. A humanoid robot requires a constant, high-voltage tether to an electrical grid just to remain standing.
But the energy crisis is only half the nightmare. The true chokehold of physical AI lies in how these machines move. Traditional electric motors are a catastrophic compromise. They are either far too weak to mimic human lifting capacity or far too heavy for a bipedal skeleton to balance. To replicate human dexterity and fluid locomotion, a robot requires specialized, ultra-precise planetary gearheads, custom strain wave gears, and highly complex harmonic actuators. Because of this severe hardware shortage, manufacturing a single advanced humanoid prototype forces costs upwards of $150,000 to $200,000. This eye-watering price tag transforms mass commercial production into an absolute economic impossibility.
Tech corporations have built the most advanced digital brains in human history, but they are trapped inside heavy, expensive, and fragile mechanical cages. Silicon Valley has the code, but they lack the industrial muscle to scale it, which raises a dark geopolitical question. If the physical components required to build the future workforce are this rare, this expensive, and this complex, who is quietly cornering the market on the raw materials and factories required to build the automated robotic legions of 2030?
The answer to the global hardware bottleneck is not being engineered in Silicon Valley. It has already been monopolized across the Pacific. While American tech giants like Tesla and Figure design beautifully sophisticated software brains, China has quietly captured the raw physical reality of robotics. To understand the depth of this asymmetric power structure, you have to look down at the periodic table. To make a bipedal machine walk, balance, and exert force, its electric motors rely entirely on high-performance neodymium permanent magnets. Without them, a robot's joints are completely paralyzed. Today, a single nation controls over 70 to 80% of the global extraction, processing, and refining of these vital rare earth minerals. If a geopolitical conflict triggers an export restriction, Western robotics facilities will freeze instantly. Silicon Valley owns the code, but an autocratic empire owns the elements required to manifest that code into reality. But China's dominance stretches far beyond the raw earth. It is driven by a coordinated, state-backed industrial strategy. China's Ministry of Industry and Information Technology has issued a sweeping national mandate to mass-produce humanoid robots. While a Silicon Valley startup painstakingly hand-assembles 10 luxury prototypes inside a sterile laboratory, Chinese megafactories can leverage their existing supply chains to print thousands of low-cost harmonic actuators overnight. They risk building a flawless digital mind, only to realize they have no sovereign capability to manufacture the physical bodies to house it. By the year 2030, this global industrial imbalance will reach a critical breaking point. These highly intelligent mechanical entities will begin arriving in our daily lives by the millions. But their arrival will not be a peaceful transition of labor. Because when an autonomous machine steps onto the factory floor, the human workers forced to stand beside it will quickly realize they are no longer just employees. They are training their own executioners.
The year 2030 will not arrive with the dramatic explosion of a Hollywood science fiction film. It will arrive as a slow, quiet, and entirely unglamorous invasion. The transition of humanoids from high-tech novelties to infrastructural necessities will begin in the shadows, occupying the dull, the dirty, and the dangerous roles that society has quietly sought to automate for decades. But this is merely the foothold.
As physical AI reaches absolute maturity, fed by billions of hours of cloned human data and manufactured by the millions through hyper-scaled factories, the bottleneck vanishes. The fragile lines separating biological capability from synthetic, tireless efficiency will simply blur into nothingness. The machines will not conquer us. We will quietly step aside to let them take over the physical world we built.